All right, so we're back to our agenda again, and our next speaker is Doctor. It's not the Sajith. Sajith, yeah, okay. Sajith is doctor, right? He's still PhD, seeking for doctor. Okay, so the Sajith and Wettewa, and his topic is displayed on the screen. So please go ahead.
Okay, thank you. So I'm a second year PhD student studying here in RMIT in civil engineering, and also part of the Center for Future Construction, co-led by Associate Professor Leho. And so I'll explain you some of our work relevant to building health monitoring. So this is not really focused on structural, but also overall building health monitoring through graph deep learning techniques. So this will be my outline. We are using graph neural network, so a basic introduction, and then building information modeling to graph neural networks, and also integrating operation and maintenance data, and some proposed analysis scenarios that we are currently working on. So this is a research that which is currently in progress. So if you are not familiar with graph neural networks, we can utilize graph data. Actually, if you can develop meaningful relationships between data points, and if you can represent these in graph format like these with nodes and edges. For an example, this is a road network. So if we divide the network into sections as seen in these colors, and then if you represent these in node and edge format using a graph, and then if you can integrate features for these nodes and edges, we can utilize these with graph neural network based analysis. So some of the popular applications are in Google Maps. If you use the estimated time of arrival, they use GNNs, and then in Pinterest for image suggestions, and then Facebook people you may know section, they use graph neural networks. Um, so a basic introduction of how it works is like if you consider one of these nodes as a neighborhood, which can be called immediate or one hop neighborhood, and the information is aggregated from this neighborhood during the prediction. So you can either consider a one hop neighborhood, or you can extend the neighborhoods to two hop, three hop likewise, and then currently there are like algorithms like graph transformers, which can be used to analyze extended graphs as well. Yeah. So we recently conducted the review study which is published exploring some of the applications of graph neural networks in building and civil infrastructure operation and maintenance scenarios. So we have developed this framework. So we have identified several scenarios such as graph database development, and then categorizing them either for spatial, temporal, or interaction based graphs, and then integrating features, and then utilizing them with these kinds of capabilities such as knot classification, regression, or subgraph graph based analysis. And we have found out some predominant applications in semantic enrichment tasks, and then some anomaly detection tasks, uh, occupancy or feedback forecasting, and also mostly the studies were relevant to building HVAC systems and things like heating and cooling load forecasting. So also we have identified some research gaps in uh, graph database development and also anomaly detection. So we are currently working to improve those areas. So this is one of the current work we are doing. We are trying to utilize building information models and also historical maintenance and operation data coming in from CMS or computerized maintenance management systems to develop graph databases out of them, and then later utilize them with tasks such as subgraph level analysis or link prediction or node level tasks like node classification like this, which can benefit the operation and maintenance scenarios. So if you consider building information models, you may have experienced there are several stages of building information models. Design beam, as-built beam, and FM-ready beam likewise. So when we consider facilities management, these as-built and FM-ready beam are the ones that we can consider for our FM scenario. So there is this data interoperability concern when we consider using these building information models with GNN based analysis. So currently we have worked to develop several scenarios for these. One approach is using the Revit API to generate graphs out of Revit API and representing them using the graph markup language. So this is one example where we can represent beam elements as nodes, and then we are considering spatial based graphs, spatial proximity or spatial connection based graphs. So we can represent nodes as building elements and then spatial relationships as edges. So we have also tested this with two methods, the Revit API based method, and then one more of open source or IFC open shell based method. This actually the summary of the method. We are performing a solid geometry intersection check, and we are producing pairs of elements which intersect or which touch each other as proximity elements, and then we are writing this into graph markup language files. And the important thing is you can also extract additional information from the building information model, which are relevant to facilities management scenarios. These can be simply areas, volumes, or other than that, like warranty information, manufacturer information, or whatever you want to the same graph ML file, and then later use this with your GNN analysis. So if I quickly explain some of our results. So we have tested this with the Revit API and IFC, as I mentioned earlier, but we have found out the Revit API method successful for most of the cases, but the IFC based method still needs more exploration to generate the spatial graphs. So this is one of the examples for an HVAC system, and then we can visualize these using software such as Gephi. This is the graph representation. So if you want to show how the graph looks like to different stakeholders, you can use these visualization techniques as well. And so once we have this spatial characteristic based graph, then we are trying to integrate some of the information coming in from these CMMS systems. So these can be work order related information or asset management information, preventive maintenance records, and reports or such data. So these can be either structured or unstructured. So depending on the type of the data, we are utilizing different techniques. So one of the techniques, natural language processing, to process some of the unstructured documents. And then we're trying to generate some meaningful features to be used with our graph neural network, so the initial graph databases. And so this work is currently going on, and we are trying to predict some meaningful outcomes, ideally to assist existing building maintenance workflows, not to entirely replace them, but first to assist them. Some of the work are relevant to like maintenance priority prediction, which can be classified as a node classification task, and then maintenance interdependency prediction, which can be classified as a link prediction task. So we are currently working on producing some of these results. And so as you can see earlier, you saw a simplified spatial graph, but when you integrate further information like maintenance events and then events and such, so you can develop more relationships like functional edges. Likewise, so this one of the extractions from this particular graph. And for the future, we are currently working on developing more open source based or IFC based graph generation, and also automating the feature engineering process and graph generation, and also focus on utilizing more Beam GNN based workflows as well. So this is one of the publications, and that's it for me. Thank you.
For keeping the time, so we have time for some questions, just one or two questions. Any question from floor? Yeah, so no question. Maybe I have a question for you. Actually, I mean, it's very glad to see the GNN. It's probably trend in the future. More people are going to use it. So from your point of view, and compared with CNN traditionally we use, what is the advantage of GNN?
So actually, yeah, so we have seen the same graph structure can be actually represented in traditional algorithms as well, but I think the efficiency, so if we want to code the same graph structure using traditional algorithms, that can take more time and work. But I think as graph neural networks are uh, created to utilize graph data, I think it's more efficient in that manner using the graph data.
So you're saying that CNN is more grid type of structure,
Yeah.
but the GNN is more so for the spatial type.
Yeah,
That's what-
using the relationships as well.
That's right.